Yeah, hopefully this is working. Okay, so this is adrenal. Okay, so we're gonna start with the hypothalamus and then just talk about the regulatory system involving the adrenal glands. So everything kind of starts off with the hypothalamus. And this time hypothalamus is gonna be secreting corticotropic releasing hormone. This is also called CRF releasing factor releasing hormone. And this is going to go to the anterior pituitary again. And anterior pituitary is going to release something to the adrenal cortex. And so this one will be ACTH. Just to remind ourselves, do you guys remember what this CRH is? What type of mechanism of action this is? So is it cyclic AMP? Cyclic AMP. And then this is also going to be cyclic AMP. Okay. And then for the adrenal cortex, there's 3 different layers in the adrenal cortex. So there's 3 different layers, and then there's going to be the medulla. So this we'll talk about later. So this pathway kind of pertains to the cortex, and then, so the cortex, there's 3 different layers, and this is how I remember the layers. I don't know if people have problem remembering the different layers. So I think of GFR. So first, when we think of adrenal cortex, we think of, oh, aldosterone is kind of made somewhere in there. So that has to do with kidney and GFRs. So GFR, and then the G for the glomerulosa, it's going to be aldosterone, and the outermost layer, glomerulosa, then it's going to be glucocorticoids, and then it's going to be the sex hormones or androgens, right? So how we remember is the deeper it goes, the sweeter it gets. Okay, so the deeper it goes, deeper, and it's going to get sweeter. So first, over here, the G, glomerulosa, is the outermost layer, and that makes mineralocorticoids. So there's nothing sweet about that. It's like salty, right? So salty. And this is the aldosterone or mineralocorticoid. So this has more to do with the salt retention and such in the kidney. And then fasciculata, it's going to be the glucocorticoid. So that has a little bit more to do with sugar. So glucocorticoid. And then reticularis, that's going to be the sex hormone. So I guess that would be the sweetest part of it. Androgens. Okay, so this is the general gist of it, and then this one is cortisol being the most important one. Okay, so we know when you have this whole system activated and you have ACTH, ACTH will actually stimulate all 3 of these layers. But in terms of regulation, the only one that feeds back, that has the negative feedback to the whole system, is going to be cortisol. So cortisol is going to be the only one providing negative feedback to both the anterior pituitary, and then it's going to be negative feedback to the hypothalamus. So the implications of this is, let's say you have something wrong with the pathway for making cortisol only. So you have ACTH being secreted, and all layers of the adrenal cortex is stimulated, but only everything else is made, just not cortisol. So your body is going to think that you're not making anything from the adrenal cortex. So it's going to continuously upregulate ACTH. So let's say you have no cortisol. For example, no cortisol. If you don't have any cortisol, then there's no negative feedback. And if there's no negative feedback, you're thinking like, oh, we need to make more. So these will be upregulated. This is upregulated. This is upregulated. So you have a lot of aldosterone, a lot of androgens, but you still don't have any cortisol. So there's that implication that, if cortisol is not working, then you'll end up having a lot of the other one in addition to atrophy. Oh no, sorry, not atrophy, hypertrophy. Okay, so we'll talk a little bit more about this. But for now, let's say we have cortisol, and cortisol has a whole bunch of effects that we're going to talk about later on. But what I want to bring to your attention right now is in terms of the adrenal medulla. Because over here, it regulates the production of epinephrine. So this step here is upregulated by cortisol, and this is PNMT. So that's the enzyme that converts norepinephrine to epinephrine. And under maximal stimulation, this can make up to 80% epinephrine in the adrenal medulla. Okay, and we're going to talk a little bit more about this too. So epinephrine eventually is going to get secreted into the blood, and we need to know what it does to alpha-1 receptors, beta-1 receptors, and then beta-2 receptors. So this is a little bit later on. So the general gist of this is cortisol is the only one that provides the negative feedback to the hypothalamus and anterior pituitary. Okay, so I'm going to go to another page in just a second. And this page is here. So this is talking a little bit about what I just said before, some of the effect of ACTH. So ACTH is the stuff from anterior pituitary, what the effects of ACTH is and what the effect of cortisol is. It might seem daunting, but there's just few really important items that if you remember those, the rest is gonna make sense. So when you have ACTH, if you recall, the whole pathway of making these steroid hormones is you need cholesterol, right? So the first thing that happens when you have ACTH over here, acute effects. So in the very beginning, when you have ACTH, what it's gonna do is it's gonna try to get more cholesterol. And then, so you're gonna have things like, oh, you're gonna convert cholesterol esterase into cholesterol, and then you're gonna increase like the beginning part of the synthesis. So this is what happens when you first have a lot of ACTH. Now, if you have the chronic effects of ACTH, so over a period of time, then you're gonna start making the enzymes for making the rest of for doing the rest of the pathway. So you're gonna have more of the gene expression resulting in more enzymes and receptors being made. And in addition to that, it's going to increase the proliferation. So what I briefly touched upon before is that if you don't have cortisol and your body is thinking that, oh, well, we need to make more cortisol, then you start upregulating the ACTH. So over a long period of time here, chronic effects is that if you have excess ACTH production, you're gonna end up with hypertrophy. So your adrenal cortex is gonna get very large due to the proliferation of basically having more cells in the adrenal cortex. And the reverse is true. So if you, for some reason, don't have enough ACTH over a long period of time, you're gonna have atrophy. Okay. So this is the general gist of what ACTH does, the acute and the chronic effects. And then cortisol, okay, let me just scroll down just a little bit. Can everyone see this? Make it a little bigger. Okay, so the cortisol, the effects of cortisol is, so cortisol is made when you're basically in a stressed situation. And for example, you know, your alarm clock goes off early in the morning and then you have to get up out of the bed at 8 a.m. So this is how I remember that the cortisol release peaks at 8 a.m. So for me, that's kind of stressful. You wake up in the morning to go to class. So I'm pretty sure at that point my cortisol is very high anyway. So whatever helps you remember, you do need to know that that cortisol release peaks at 8 a.m. So it peaks at 8 a.m. But then also other things that make you release cortisol is, you know, stress. So stress. So it's basically a response for stress. And what your body is doing is it's trying to get ready for what's to come. So if you're thinking that you're stressed out, so maybe there's something that's gonna happen later on and you might need a lot of fuel. So basically it's, in terms of its effect on metabolism, is that it's mobilizing fuel. So what that means is it's going to make glucose more available in the blood. It's going to make amino acids more available, and it's going to make fatty acids more available. So basically all the basic fuel sources is going to be upregulated. It's going to be, you're going to have more concentration of these fuel sources in your blood. So in terms of increased blood glucose, what it does is gluconeogenesis in liver. And at the same time, you don't want your skeletal muscles to be taking up the cortisol until you need it. So at the moment when you're anticipating that stress later on, you want to decrease the glucose uptake by the skeletal muscle. And in terms of how you're increasing the amino acids, your muscle is kind of basically give up these amino acids. And then fatty acid, you're basically going to increase the hormone-sensitive lipases in the fat cells. So it's going to start breaking down into fatty acids. It's going to start breaking down the lipids into fatty acids. So this is basically what you need to know for what it does to metabolism. And just one small thing to point out is if you remember growth hormones, it does many of the similar things as cortisol. The only thing that is different is it doesn't have this effect. So growth hormone will not increase your blood amino acids. So that's the only difference. Okay. So the other effects of cortisol, I don't know if that has to do with stress, but the other effects of cortisol is what we sort of use in terms of drugs and therapy. So it has these inflammatory, anti-inflammatory effects, and it's immunosuppressive. So how that was explained is it basically stabilizes the lysosome, so you're not releasing these inflammatory, so you're preventing the release of inflammatory factors. So just something to know. And it also helps other hormones. So in terms of alpha-1 adrenergic receptors and helping it maintain the vascular tone. Okay, and then the only disease that's really important for this is Cushing's syndrome. So Cushing's syndrome is basically an excess in cortisol. So when it's called syndrome, it's just increase in cortisol due to whatever reason. It could be taking in too much, or if you actually have a problem and you're secreting too much. So syndrome means just an excess of cortisol due to some mechanism. Okay, and then this I'll explain later if we have time. Okay. All right, so does anyone have questions about the whole cortisol system and how the regulations are. Oh, okay, so let me quickly go back to this page where we drew out the effects of cortisol and the regulation. So what I want to briefly talk about is what these other things do. So androgens, we talked about cortisols already. We talked about what cortisol does. And now we're going to talk a little bit about aldosterone. So aldosterone, basically what I want you to remember is in the kidney, it's going to result in sodium retention. And it's going to result in more potassium excretion. So this will result in increased concentration of sodium, and this will result in decreased concentration of potassium. Oh, wait, hold on. Yes, this will result in decreased concentration of potassium. So for now, this is all you need to know when you do the kidney section. Next block, you'll need to know it in greater detail. So for now, just know these effects from aldosterone. So cortisol we talked about, and then the next one is we're going to talk a little bit about what the effects of epinephrine is. So epinephrine here. And there are 3 types of receptors that are really important. So you have alpha-1 receptor, so alpha-1, and alpha-1 responds more to norepinephrine. So alpha-1 responds more to norepinephrine than epinephrine. And alpha-1 is mostly in the eye. And what does it do in the eye? Dilate. And has effects on blood vessel. And what does that do? Constricts. Okay. And then bladder. So when you're running away from a bear, do you want to be peeing and leaving a trail behind? No, probably not. Okay, so retention, right? Okay, so this is what you need to know for alpha-1. And then let me go over here in beta. Beta-1 has mostly, it responds about equally to norepinephrine and epinephrine. And mostly what it's going to do is think of heart, and it's going to increase heart rate. Let me see if I can move this over. And beta-2 is going to do the opposite to blood vessels, so it's going to dilate. Beta-2 also responds a lot more to epinephrine than norepinephrine. So it's going to make the blood vessels dilate, and it's going to also dilate your airways. So airways, it's going to dilate. Okay, so these are the most basic effects of these adrenergic receptors that you need to know. Later on in pharm, you have to know much more. But for now, I think this is enough. And I'll post something with a little bit more detail later on, just so that you have something to refer to in case you need to know a little bit more than that. All right, so now we know what the aldosterone does. Mostly that's going to increase in sodium and decrease in potassium. Cortisol, we talked about what it does, and then we talked about the effects of epinephrine. Okay. Yes?
I'm trying to remember where in the like what blood vessels would you want to dilate the response?
I think it's more the blood vessels going to your muscles, skeletal muscles. And then alpha 1 is more like
Like blood pressure
and skin too. Yeah. So it depends on what you're doing. Some areas you want to direct more blood flow, some areas you want less blood flow. So that's why in terms of blood vessel, it seems like it's contradictory. But definitely know the airway and yeah, dilate blood vessel, but skeletal muscle. I'll post something later on that gives a little bit more detail, but yeah, for now this is the most basic stuff you need to know about what it does. Okay, so are there any other questions with cortisol and cortisol related pathways? So if we have time, I might run through the mechanism of making each of the corticosteroids. But if not, the video I made before does explain all three things. Let me just pause this.
Stop.
Stop.